Hi everyone. In this given problem statement, we are going to solve word search 2. Given an m cross n grid board of characters and a string of words, return all the words on the board. So we have to match these words. So there could be a lot of way of doing it, but if I do this problem using a prefix tree or a triad tree, right, it would make the solution kind of a linear time solution. So it would be just going to search all the indices or all the boards. So let us create the prefix tree. The first thing we're going to do, right, we from the words, we're going to create the prefix tree. So the first one is going to be O, then A, then T, and then H, then P. Let's say this is the starting tree node, right? So it would be P, E, A, then eat, E, A, T, and at last there is a value called rain. So we can create R, A, I, and N. Now we are going to do a kind of a search, like we need to two nested loops, right, to search. So once we are at 0th index, right, so we can say for I in range 0 to row, which from here you're going to length of the row, for j in range 0 to column, right, I can do a DFS search with row and column, or let's say I and j. I also had to pass in some more parameters. I have to pass in what is the current prefix values, current prefix tree. So I can say cur equal to root of this prefix tree. So I can pass in the cur, and initial value is going to be an empty string. So this is the one that you're going to pass. How is it going to work? So in the DFS right function, we know, right, we can have some parameters, right? Here I have to call DFS. So the movements can occur in 4 direction, right? It can move on the top, down, left, and right. So I can say R plus 1 C DFS R minus 1 C DFS R C plus 1 DFS R C minus 1. So that is the idea. Let's say I am at O. Okay. So I'm going to check, right? There would be a condition, right, which we know that when you're checking for this type of problem, right? So I have to check if, and it would be inside the DFS function only, if R is less than 0 or R is greater than equal to my total length of the column, or C less than 0 or C greater than equal to C, or R comma C in visited, or, and here the prefix comes, right? So or board of R and C not in cur dot children, then we can return, sorry, then we just can return not true, means it is an false condition and nothing is going to happen. So in this case, right, if I add O, right, so is this condition working? So if I look into it, right, as of now visited set is empty, right? So board is not in, and if I look into it, right, if I look into the tree node, right, it has children of O, P, E, and R. So O is in our children. So what I can do, I can say the given empty string, right, I can say it as word plus equal to board of R and C. Then I can also add this to the visited dot add board R and C. And the most important part, I can say cur. I have to also increment the cur. So cur equal to cur dot children of board R and C. Initially, right, my prefix was at this. So once I do this, right, so cur dot children, my pointer, right, is going to point to this one at its 0th position. Then once I am at 0th position, right, the next value that I'm going to get, I am also going to downward side, left side, top, and those will not going to work because if I go to E, right, E is not in cur dot children, so it is not going to work. If I go to the A, right, it is going to work, and A is in cur dot children. So I'm going to, the pointer is going to point to this one. Then similarly, if I have to move down, all the other right is not going to work. I have to come down. Now the current cur value would be at this position, and then also I can go to H. Once we had got H, right, here I can also add one more condition. If cur dot end of word equal to true, that basically means we're at the end of the word. So we can also have our result, which you can assign it as set for now. So I can say res dot add board of R and C. So that's the basic idea, and it is going to get added in this way, right? Our result is going to have O, A, P, H. Similarly, we can iterate over the other ones also, and we are going to get the result. So that is how it is going to take place. And if you look into it, right, it is going to be a kind of a linear, like it would be big O of M cross N. And also, right, to find the words, right, we can have multiple words. So in the output, right, I can say another some complexity with the length, but that would be a very minimal. So it would be a big of M cross N kind of solution. So now let us jump to the Python solution, where if I write the code, everything is going to get even more clearer. The first thing we need to do, right, we need to implement our try node class. So class node, and here we can say def init self dot children equal to, and self dot end of word equal to false. Once those are done, right, I need to find the dimensions. So R equal to length of board and C equal to length of board of 0, root equal to for word in words, cur equal to root for C in word if C not in cur dot children cur dot children of C equal to cur equal to cur dot children of C cur dot end of word equal to true. Cur equal to root visited comma res equal to set comma set. Before that, right, let me iterate over it. So for I in range 0 to the length of the rows, for j in range 0 to the length of the column, and here I have to pass in the I, j means row and column, along with right an empty string where if it matches right we are going to add the value and our current node or the current pointer. So that's the idea. Once that we have done right, we have to also write our DFS function. So def equal to DFS of R, C, word and cur. If R less than 0 or R greater than equal to capital R or the length of the row of the board, or C less than 0 or C greater than equal to C, or R comma C in visited or board of R and C not in cur dot children, we can simply return the value vi visited dot add R comma C word plus equal to board of R and C. Here we have already established right that the word is in prefix tree, so we can, or the character is in proper in cur.children, so we can add those values. And I can also add cur equal to cur dot children of board R and C. If cur dot, and here right we have already added those values, but how will I understand right whether it is an end of the word? That can only be done if I check cur dot end of word equal to true. In that case what I can say, res dot append, or res dot is a set, right? So res dot add word, and after that we can do our DFS function. So R plus 1 C comma word of cur, DFS R minus 1 C word and cur, DFS R C plus 1 word and cur, DFS R C minus 1 word and cur, and at last we can say visited dot remove r and c. So that's the basic idea how it is going to work. Although this code might look a bit bigger, and which is honestly it is a bit complicated, but the idea is that it should work. Let me see where it is throwing an error. Okay, I have forgot to return the result. So return, it is in set, so I have to convert this set to a list. So, and I can return it back. Let me run it up. The public test case is passed, and this is the output. So this would be the try node, and which would be same if you're implementing any try node solution, and this would be the result. So let me submit the code. As you could see, it ran successfully. Although it is saying beating 24, let me run it again. I hope it is going to improve. Anyway, right, this it is hovering in that range. Maybe it can be optimized a bit further. Anyway, I think if you have a better way of optimizing it, right, it is going to get solved by try node. But if there is a better optimization through which we can improve these runtime, right, let me know. That's all for this video. See you in the next one.